power grid is experiencing an enormous amount of challenges related to extreme weather events that are causing devastation in communities, infrastructure that's been aging for decades, and at the same time, we have vehicles, buildings that are being electrified, and data centers that are causing unprecedented load growth in the sector. And what we really need is data and information related to the system and how to make the right investments to increase the capacity and the reliability and resilience of the system at the lowest possible cost. And that's what Ryome's here to do.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Welcome, Energy Insiders, to another edition of the Insider's Guide to Energy. I'm your host, Chris Sass, and with me this week is Mishal Thadani, co-founder and CEO of Ryome. Mish, welcome to the program.
Thanks for having me here, Chris.
I'm excited to have a conversation whenever technology can help the energy and the utilities do something different. I'm excited. In this world of machine learning, AI, and all kinds of electrification of everything, the scale of the problem that we're facing is huge. Your opening statement, you talked about quantifying some things, reliability, resilience. What does Ryome do, and how does it help us quantify those things?
Yeah, thanks for the question, Chris. And really starting on the fundamental of what does the grid need today and what's it going to need in the future? And the reality is that we are facing unprecedented challenges on the grid. Extreme weather events are increasing in their frequency and severity. Meanwhile, the grid, which actually 70% of it was built by the 1930s. So we have infrastructure that's existed for almost 100 years, if you think about it. It's put us in a position where the reliability of our grid is actually dead last when it comes to comparing to other developing countries. So what we do at Ryome is we really, on a high resolution basis, identify the vulnerabilities on each and every asset of a utility's transmission and distribution system against a variety of climate hazards like winds, storms, extreme temperatures, and so on. And when you get that picture of risk, you're able to make long-term decisions, understanding how climate models are changing that future profile of risk, and are able to inform decisions like where do we underground things? Where do we rebuild lateral lines, especially where there's in a corridor of vegetation? And where do we start to put distributed energy resources and distribution automation devices like switches and reclosers to help mitigate those impacts if they do occur?
All right, so you gave us quite a bit that you do. There's a lot to unpack there. You started by talking about the grid as an old, old infrastructure in place. You talk about in the singular like a grid, although I'd argue that there's probably more than a grid, but it's one system or one being, I guess, for lack of another thing. Is that a true assessment?
Yeah, for all intents and purposes, the grid isn't a national grid, but it operates and functions in similar ways from a transmission and distribution operation perspective anywhere across the country. So even though we have an Eastern Connect and a Western Connect, we have different system operating organizations that manage the power flow on the grid at the bulk scale. The grid is operated under a common set of principles, under a common set of assets, such as the poles, transmission towers, transformers, substations, so on and so forth. So in that sense, I do think of the grid as one entity. And in that sense, the solutions in which to make the grid more resilient stay pretty consistent no matter the geography that you're looking at.
All right, so that takes me into what I asked you in the opening about resilience and reliability, right? When you're saying it wasn't actually designed for that. So does that mean they're designing for reliability and less so for resilience, that they're building to try to give me power when I turn my light switch on, but every now and then this huge hurricane is going to come take the thing out and I'm not designing for that?
I'm sure this conversation is going to take many swings into the regulatory aspects of the utility sector, but this is really one of the areas where regulation is key. So utilities for decades have been managed under a specific set of metrics related to reliability, and these are the duration and the frequency of outages on a given year, and where they're experienced. Now, when those metrics are actually designed and reported to the PUC or to FERC, they actually oftentimes exclude the major event days, so as to keep a consistent level playing field across the country for different operating systems and different service territories. So, really managing for the blue sky days, the everyday outages, as opposed to the extreme weather days that actually cost the majority of outages on the system. So, on a national basis, uh, 75% of all power outages are extreme weather induced. Yet, when you're reporting those metrics and when you're being judged on the reliability or the resilience of your system, those the major event day outages are actually taken out of the equation.
Now, in going through the challenge statement, reading through some of the literature that Rhizome has on its website and articles, you talk about the different things you measure. What are some of the disparate data that you use to come up and help the utility make this forecast or understand their risk better?
Yeah, and it's really an extension of what is the actual goal here. So, if the actual goal is to get to a system where, given any type of hazard, say you experience a hurricane or a storm or a winter event, how do you mitigate all of the impacts from people losing power, from the restoration costs that go in that end up costing, oftentimes billions of dollars these days, and then making sure that people can stay safe and healthy during those circumstances. So current reliability metrics, and when you quantify, the reduction in outages from investments that are being made today, don't really take into consideration those benefits. And so when we design our risk models, we're saying not only, what are the likely outages that utilities are going to experience on a blue day basis, but given the likelihood of extreme weather events and given our understanding, and this is where the machine learning aspect comes into play, what we've learned in history from previous extreme weather events and hazards and how that's had an impact on the system at high resolution, what's going to be the anticipated cost and loss related to the system and its customers, and use that as the risk profile from which to draw down risk through investments. So you're going from a place of saying, hey, we're going to make sure that we maintain a certain outage reliability metric, to now saying, hey, we're going to forecast what's going to be the total amount of risk derived from all of these various climate hazards, as well as on a normal day basis. And as we're doing our investment planning, actually quantify the benefits from reducing those specific risks. And that's something that we're still in the early days of doing at scale, right? So when a utility actually proposes an investment plan to a regulator, and these investment plans are numbering in the billions today. For instance, Centerpoint Energy just dropped a $2 billion resilience plan in Texas. Then they can actually come to the table with metrics related to the benefits and an optimized view of how those investments are going to actually create consumer benefit and societal benefit when they actually get implemented.
All right. So we have a high level goal of what the utility is trying to achieve or risk quantified or what you want to do. When I look at someone like Rhizome, you get all the way down to the elements health, right? You go down. I was interested. I didn't realize that poles age and perform differently over time. I didn't realize that obviously transformers heat events could affect them. There are different elements. How important is the ability to go down to the element to your solution and to the ultimate outcome that you just described?
It's very important. Utilities are making decisions at high resolutions. Therefore, the models should reflect those high resolutions. There are oftentimes a pole will be degraded because of soil conditions, because of its orientation, proximity to vegetation, what have you. And if a utility wants to go out and replace a single pole, it should do so in reflection of a risk profile of that pole in conjunction with the other assets that are nearby. So the resolution really matters here because on an everyday basis, the asset management team and the engineers at a utility are actually evaluating what are the grid needs from a portfolio asset optimization perspective. That is, let's look at every single asset, understand which is the most vulnerable and which has the highest level of need in order to prevent a potential failure. Not to take this directly into wildfire risk already, but the resolution matters particularly in the context of wildfire risk, where if one of those assets fails and say the conductor is not insulated, then it has a high likelihood of igniting a wildfire and then having that wildfire spread. So the problem is getting much more precise, and so the solutions must be a lot more precise in how to make those investment decisions, again at high resolutions.
Now you've got some marquee customers. You're not just on the whiteboard at this point. Have you learned some system wide things as well? So I get the element that makes a lot of sense to me. Saying, okay, this pole maybe needs to be repaired, or we might have fire risk or whatever. Um, but things behave differently as a system. So now when I have thousands of elements, are your data sets rich enough yet that you can start saying, hey, when these kind of things happen systematically, there's something that you need to do?
What our platform is designed to do is learn from history and how specific asset failures have led to some of the more systemic failures that you're talking about. So say if a substation got flooded and that impacted a critical facility that was connected to that circuit, so say it was a hospital or even a water treatment center, then what are those compounding effects that it has on society? Now luckily, utilities have gotten really good about identifying that critical infrastructure and making sure to best protect those resources that provide societal value. But one of the things that we're looking to uncover here is how do you systematically quantify the benefits of investing in the areas that are going to actually mitigate those more systemic, widespread problems when a certain power outage occurs. So again, we look at very high resolution, not only at the asset, but at every customer that's connected to a circuit, including those critical customers. We also look at some of the vulnerable customers, right? And when you have a hazard event where, say, it's a storm that causes flooding, and you have vulnerable communities that don't have access to resources the same way that wealthy communities do, then you have some real health and safety concerns. Folks that are connected to dialysis machines, older folks who are connected to respirators and other life-saving devices, if they experience power outages and lose access to those devices, they have a limited window in which they can actually stay alive. So their ability to attain resources during those events is extremely important. And given that example that I just stated, if there was a flood happening, and whether they could drive or not, if they couldn't access a facility that actually had those resources or had power to connect those resources, then we have some real problems. So within our tool, what we've done is start to understand where are the communities that need the most support from a vulnerability perspective. How can we model that social vulnerability and take into account some of the health and safety impacts of extreme weather events, and then use that as benefits when utilities actually make investments, so that as these investments are again put in front of the regulator, they can understand, if we're undergrounding this feeder, we can actually prevent a significant amount of the outages that happen, particularly to vulnerable communities. So within our platform, a lot of this is done on an ad hoc basis on hand, but within our platform, we're making it systemic, allowing these decisions to be made easily and for the analysis to be done rather seamlessly, and then, of course, filed in front of the regulator on an accelerated time basis.
How much is this of the platform? I mean, a lot of data science is knowing the right questions to ask. And so machine learning's been around quite a while. It's not brand new. I mean, there's a lot of cool buzzwords around AI and machine learning, but it's not a new thing. It's understanding the problem you need to solve for. Are are we using AI to help find problems or uncover problem statements in your software, or do I need to know that, hey, here's my thesis and we're going to vet the thesis?
Yeah, that's a great question. There are hundreds of use cases, maybe even thousands of use cases for AI in the utility sector, and through Rhizome and through previous organizations, I've explored a lot of them. And where you always want to start with utilities is really identifying what's going to be the actual use case from a business perspective. And there are two major areas where AI can come into play. It can help automate things, that is, take some manual tasks and do so on an automated basis, or it could help predict things. Take a bunch of information where utilities typically relied on subject matter expertise and actually make data informed decisions about the future and help plan for the future. Um, with those two things in mind, we approach the utility industry with the business mindset to understand what are the planning workflows within the engineering and asset management team, and start from there and work backwards. So, with the stated goal of trying to get to a cost benefit analysis that was high fidelity enough and precise enough to pass regulatory scrutiny, we did our model building. we didn't come at this with AI as a solution, fit for a problem. We started with the problem and backed into the solution. So from that cost benefit analysis, you have investments, and you can learn the behavior of those investments. What, given that treatment effect, what was the actual uh, measured benefit from the historic investments, right? And moving even backward from the investments is the risk profile. And that risk profile comes from the learnings in history, from the hazards and the interaction on the assets and the asset failures. And in order to get to that point, that's where AI is the really useful tool. So again, if for anyone out there looking to start a company in AI or trying to apply AI for a specific problem, unless you have a really specific use case that's really high value for, of course, an enterprise customer like the customers that we're working with on an everyday basis, then I wouldn't recommend introducing AI into the conversation until it's you're dead set that that is the right solution for the problem set.
Cool. So you gave a nice walkthrough of what it is. Let's make this more tangible. Let's look at like PG&E or somewhere where you got this aging infrastructure running around. There's wildfires that are going to still occur because it's just going to take time to do that. So maybe you look at burying all those wires, and that's a tremendous cost. Maybe you look at microgrids or something like that. How does a solution like yours help me what if and figure out where I should be investing?
Yeah, I mean, you're speaking to the entire cost benefit challenge, right? And how do you actually quantify that? Which is essentially where we're trying to pin the entire intellectual property behind the platform. In other jurisdictions that are not California, you have utility regulators and public policy advocates who say that utilities are spending too much whenever they propose their $1 billion resilience plans or infrastructure plans. In California, you actually have public policy folks who are saying that the utilities should be spending more, that they should be undergrounding more, that the 7.4 billion that PG&E is spending in their current wildfire mitigation plan isn't actually enough. So the real question is, how do you actually get down to brass tacks and for the decisions that the utility is making on an everyday basis can have each stakeholder involved really comfortable around the level of spending, around how much risk is being mitigated. So with PG&E, there's a classic example here, right? Uh, they have lots of medium voltage distribution lines spanning large distances to get out to rural areas. Oftentimes, there is vegetation along these corridors and relatively high wildfire risk for a relatively small set of customers in those rural areas. So they've strategically made the decision and have done some analysis around actually burying those lines as one option, continuing to maintain those lines on a regular basis, maybe doing more vegetation management as I would say the pseudo status quo option. And then the last option, which is now being considered and actually implemented, is to actually deploy a microgrid at those for those rural customers and decommission the line entirely, save on the O&M spend, completely remove the wildfire risk, and actually have that be the best decision based off of the represented costs and the benefits of deploying that microgrid. So, as the most clear cut example, like those are decisions that we're enabling on any condition on a distribution system. Most of those decisions are not as stark, right? Whether or not to cover a conductor, to deploy a recloser, to continue performing vegetation management, whether it's trimming trees or removing trees, those are decisions that utilities have to contemplate on an everyday basis that they don't have complete information for on the actual trade-offs on the cost per investment versus what's actually being mitigated, right? So that's where we're looking to plug in.
Let's talk a little bit about the journey. You're a startup or a younger company, I should say. Um, how do you introduce this concept, and how receptive are folks to having technology coming in to do this for them?
I'd say they're very receptive, right? Um, on one level, we're introducing new technology, new approaches, new methodologies that they've never used before. On another level, they are actively experiencing the changes in extreme weather events, and you never hear from a utility that that they don't experience a change in extremes, and that there's a need to better plan for it in the future. So again, starting with the use case, making sure you're bought in on what actually needs to change from a business perspective and on from a grid planning and operational perspective, and then backing into the solution from there. So when we ultimately offer an AI-based solution, they're mostly already bought in onto how it would actually make an impact on the business. So while it's never going to be easy, selling into utilities, when you have a really high priority issue, when you have executive level buy-in, and when have a product that looks to make the lives of who you're selling to a whole lot easier, as a lot of our customers' time is spent not just on kind of designing projects and pulling data and doing calculations on a manual basis, but even in front of the regulators. They're in a rate case or have filed a plan, and you have interveners, commission staff that are filing data requests related to the plan, that takes the bulk of the engineering and asset management time to respond to those data requests. So again, these are just aspects and features of our solution that make our customers' lives easier, and oftentimes the way that we position it, so that when they think about the alleviation of all this time that they could be putting in for the initial cost that we have, that's actually a pretty good prospect for them.
All right. So we got the utility perspective. How does Mish end up in this space? How did you decide to start a company solving this problem?
Yeah, look, I've been a climate and energy guy my entire career, actually going back to college. Studied at Rice University, and uh, being in Houston, you're at the center of the global energy economy, right? And I've always had an interest in environmental issues. Always wanted to fight the good fight, and I thought clean energy actually and new technology from a decarbonization standpoint was the way to go, and so that's really where I jumped into. What I've since learned is that in order to get to that decarbonized economy, we need to actually, bridge the gap between mitigation and adaptation, right? So carbon mitigation being, reducing emissions, adaptation being actually deal with real consequences. And actually, by doing so, by increasing adaptation and resilience, especially in the utility sector, which is really the cornerstone of our entire economy, how society functions, and also the source of the bulk of our emissions. What we need to do is ensure that the grid still continues to function as it is today. If it does not, if say we get to much more of a decentralized grid, we're effectively going to double the cost of fighting climate change. So I'm not just coming at this from a health and safety perspective, making sure that we account for vulnerable customers and communities, and utilities can of course make the right decisions in the right locations. From a thematic perspective, uh, I'm much more focused on how do we make the grid more resilient at as low of a cost as possible in order to enable that decarbonization that needs to occur, this grid transformation that needs to occur. Because unless people can start to experience fewer power outages, have an easier time with emergency response, and can stay especially healthy and safe during those extreme weather events, people are just not going to care about decarbonizing the grid as much. So that's really where I'm coming at this from.
And I hear in your statement say that in order to achieve this, your hypothesis is we need the grid to be more resilient, but we need the grid. You don't want to distribute everything. You don't want to have a bunch of siloed solutions. Is that what the takeaway was from that first part of your statement?
The major takeaways is that we need to have a very measured approach in how we invest in the grid and make decisions. So where it makes sense to deploy microgrids in some parts of the grid, especially for rural customers, it definitely doesn't make sense in some of the more urban areas, especially from a grid planning perspective, right? From a social buy-in of having people have affordable, reliable, safe power, right? If you want to go on a microgrid and you're in the middle of the city for your own benefits, my former college campus was on a microgrid. We actually had power during hurricanes. That is a very wise decision to make. But when it comes to the utility regulatory compact and what should be invested in, and that decision making process, we need to be really nuanced about what are the investments to make that actually maximize the benefit to customers for the cost going in.
All right. As a former founder myself and someone that works with a bunch of energy tech companies, the one thing that we almost always find something we didn't expect. We always have a surprise or something that we learned. What have you learned now that you have the technology out? What did you learn that you didn't expect? Or what has the technology uncovered that you weren't thinking you would?
What this might sound really specific, but is actually extremely powerful. And the power of data and these distributed cloud systems and artificial intelligence is one of the things that we can actually do is simulate storms that have happened in the past where utilities have made various investments since then and actually observe if there would be a reduction in power outages. And so we can do this on a historic basis, but we can also do it on a forward looking basis. That is, if a utility undergrounds these lines or if they upgrade the class of their poles in these areas, we can actually simulate a storm that's happened in the past and anticipate how many outages would have been reduced. And so before I met my co-founder Rahul, this concept was completely foreign to me. I didn't think you could take data and apply simulations in this sort of format. And so that's the one thing that I'll say is, utilities are creatures of scenario planning and wanting to best prepare for the worst situations and what could happen. One of the things that I'm really excited about that I did not know before going into this is that we would really be able to simulate the impacts of those events when they actually do happen. So that was pretty exciting for me.
Was there any law of unintended consequences where a utility made a plan to harden things or make it better, and you ran the simulators later and said, well, you might have solved for this risk, but you created a new or additional risk? Have you seen that yet?
Not yet, but that being said, we're still early in our journey. We're deploying our models and have started to generate some really powerful insights for our customers, but haven't come down to those specific conclusions yet. So if you talk to any company working in the utility sector, one of the things that they'll tell you is you haven't really done the work until you have uh, really resisted the burden of a regulatory filing or a rate case. And we have, I'm happy to say that by this summer we'll actually be going through that process. But until then, I will stay shy of commenting on some of the outcomes here.
Well, awesome, Mitch. This has been a lot of fun for me. I want to thank you for sharing with myself and our audience. It's been a great conversation. Thank you so much.
Thanks for the invitation, Chris. Really great to be here, and thanks again.
We look forward to hearing about the future growth of your company and development as you move forward. For our audience, if you like this content, don't forget to subscribe and do something really easy. It's a small thing for you, but it helps us quite a bit. Is like the content. Give us a like, give us a comment, and we're going to see you again next time on the Insider's Guide to Energy. Bye bye for now.